Have you ever wondered if there is a battery that could be 3 times better than the ones we have now? Well, it seems like there might be. It's called a lithium-sulfur battery, and it could revolutionize how we power everything from phones to electric cars. Despite its potential, this technology has been tricky to develop, but thanks to an accidental discovery, it might finally become a reality. Let's find out what all the hype is about. Sulfur is an uncommon material that can store a lot of energy when used as a battery, which is much more than lithium. Therefore, the lithium batteries in our phones and cars can be replaced with sulfur batteries, which will last longer or be lighter for the same charge. As an illustration, if we take a battery of a computer and substitute it with a sulfur one that weighs the same, it could work for more than 3 times longer. For instance, we could use a much lighter battery that will still allow the computer to run for the same time as before. On the other hand, electric cars are a must to consider. The most advanced today are capable of running up to 500 miles in one charge. However, if we replace the current lead batteries with sulfur ones without the change of the battery weight, these cars could travel up to 1,500 miles. Another thing, some people say that thanks to sulfur batteries, cars could go even farther, let's say up to 2,500 miles on a single charge. Using sulfur as an alternative to lithium in batteries could be of benefit in many ways. The first fact is that sulfur is much more abundant than on the Earth, almost as common as iron. The excess of this material could in the future help lower the battery prices. On top of that, it might help us be less dependent on resources like cobalt, nickel, and manganese that have supply problems and are sometimes linked to humanitarian concerns. This is another reason why sulfur is used in industrial applications, because it is a lot cheaper than these other materials. One example is cobalt, which has a price of about $75,000 per metric ton, or lithium, prices of which have reached close to $40,000 per metric ton recently. On the other hand, sulfur is a relatively inexpensive material, which costs approximately $382 per metric ton. To illustrate, for the same amount of money, one could purchase almost 200 tons of sulfur instead of a ton of cobalt. Hence, battery usage of sulfur would help us to reduce costs, lessen the use of scarce materials, and solve the issue of supply chain. It could result in wider distribution of battery technology and its sustainability in many fields such as personal electronics, electric cars, and grid storage. A group of scientists from the Drexel University's College of Engineering under the leadership of Dr. Vibha Kalra, whose mission is to optimize the lithium-sulfur batteries, was working on this. These batteries are very successful, but may have a few drawbacks after use. The act of charging and discharging the batteries causes the sulfur to experience chemical reactions and eventually produce substances known as polysulfides. Such compounds form tree-like structures that lead to the breaking of the battery's elements after some time. Nonetheless, the scientists from Dr. Kalra's team unintentionally came up with a remedy to this issue while they were trying to solve it. This breakthrough can make lithium-sulfur batteries so much more reliable, which is great, because electric vehicles already bring us many benefits, and this development can only make them better in the future. Lithium-ion batteries, which have the capacity to be charged between 1,000 to 2,000, are inferior to lithium-sulfur batteries that even in the best laboratory conditions fail to perform to the desired level. In real life, it means that lithium-sulfur batteries will not be functional within a year or two of regular use. To reduce the shuttling phenomenon, which is the most commonly occurring one, the use of other electrolytes that can dissolve polysulfides is the common approach. Nevertheless, the electrolytes may have drawbacks as well. These devices are usually expensive, which makes them less affordable to carry out large-scale applications. In addition, they're risky because of the fluctuations and the instability they bring. Furthermore, the amount of battery needed to fulfill the shuttling task might decrease the energy density of the battery, which could spoil its primary function. However, the doctor answered that the batteries had to be made working using a carbonate electrolyte, which is more often used in lithium-ion batteries and which is more environmentally friendly. The purpose of the experiment was to make the polysulfides react with the carbon nanofiber, which would stop the sulfur from reacting with the electrolyte. But the experiment did not yield the results Dr. Carla was expecting. However, their conclusion was something unexpected and totally unforeseen. The sulfide was stabilized into monoclinic gamma sulfur with the structure of a rectangular prism which consisted of 8 sulfur atoms packed together. When it was combined with the carbon nanofiber, the problem is sulfur has this kind of instability at normal temperature. In reality, it is generally generated only in laboratories under the hottest conditions and only in very natural situations such as drilling oil wells. Code author Roll Pye from the Department of Chemical and Biological Engineering said that the number of studies which have created monoclinic gamma sulfur is very low, and these studies have made it stable for a maximum of 20 or 30 minutes in the past 100 years. On the other hand, this was done in a controlled lab setting without the presence of the environment in which it actually exists. Therefore, it is this discovery that is of such great importance. However, the polysulfide and shuttling effect are missing because the crystalline form of sulfur with which the carbonate electrolyte does not react in the same way as other forms of sulfur is omitted. How does this issue impact the battery's performance? The researchers succeeded in running an electrolyte lithium-sulfur battery with a carbonate electrolyte for 4,000 cycles without any performance degradation, which is equivalent to 10 years of use by introducing carbon nanofibers to the electrolyte. In addition, the tested battery has 3 times the capacity compared to the current lithium-ion batteries. That's that, then, correct? Issue resolved. Here, instead of lithium batteries, we will use lithium-sulfur batteries. Not exactly though. Like most unintended discoveries, the team now has to know the reasons why the experiment resulted in the way it did. What was the sulfur stage appearance? This is the question. Whether these entities are able to replicate it, are they able to ensure that it will stay intact as well? Finally, there should be more research about these batteries before they can be sold. Nevertheless, the investigation is not yet completely over. The team aims to take this step forward and investigate alternative lithium-free batteries, such as sodium-sulfur ones. Lithium-sulfur batteries might be the next big thing, yet it still is far from being commercialized. Nevertheless, this accidental discovery proves that it is possible to make a great leap forward. This is also a battery, but not one that you can use right away, just like the majority of batteries that we have talked about on this channel. Nevertheless, we can figure out that batteries of this kind do have a lot of consequences. All producers of electric cars are having a hard time getting the materials they need due to the supply shortage. The main problem in the supply of the battery materials constitutes the most significant barrier for the automotive companies to make more electric vehicles. It means that the battery may not only be superior in its performance and longevity, but it must also be able to fill the niche of the current technology. Nevertheless, the EV and battery shortage industry may be transformed by the growing diversity of components and the influx of new battery material.